College Algebra, Chapter 11, Section 1, Part 1, Synthetic Division. Divide 2a squared plus 8a plus 13 by a plus 2. You know, we could do that by long division, but we don't want to do that. We want to do it the shortest, easiest way possible. So we're going to do synthetic division, taking the opposite of the constant in the divisor, put the coefficients of each of those terms, skip a space, draw a line, bring down that first number. After that, it's multiply and add. Negative 2 times 2, negative 4. 8 minus 4 is 4. Negative 2 times 4 is negative 8. The last number that you get, put it in a little block over here because it's your remainder. Your answer is 1 degree less than what you divided into, so that you have 2a plus 4 with a remainder of 5. My math lab would always want you to write that as 2a plus 4 plus 5 over a plus 2. Final answer. Let's do one more of these. That was example 1. Example 3. X to the 4th plus 81 divided by x minus 3. Same procedure. Take the opposite of the constant in the divisor. Means I put a 3 out here. I have to put a 0 to hold the place for these missing terms, so that's 0x cubed, 0x squared, 0x, and an 81. Skip a space, draw a line, bring down that first number. 3 times 1 is 3. Add, 9, add, multiply, 27, 27, 81. I'm adding all the way across so that I have 162 over there. My answer will be x cubed plus 3x squared plus 9x plus 27 plus 162 over x minus 3. In this lesson, 11.1, we're going to be doing these, but they're going to ask us to express the answers in a little different form. So example 4 is express in the form f of x equals x minus k times q of x plus r. My function is f of x equals 2x cubed plus 3x squared minus 16x plus 10. They're telling me that k is negative 4. I'm going to do synthetic division. Then I'm going to write my answer in this form. They've used that q of x because q is sort of going to stand for quotient. That'll give us an idea that that's where we're going to put the answer to this synthetic division that we do. So we're doing synthetic division. When they give you k, you don't change the sign, you leave it like it is. So we got a 2 and a 3 and a negative 16 and a 10. Bring all these numbers down. Do this same little procedure that I've been doing. I'm going to get a remainder of negative 6. Now, I'm ready to write my answer. My answer is x minus k, so it's x minus negative 4 times the quotient, that means times this answer I got, which is 2x squared minus 5x plus 4, plus the remainder, and this time we get to just leave the remainder like it is, so it's plus negative 6. You know that you don't leave two signs side by side, so it's x plus 4 times 2x squared minus 5x plus 4 plus negative 6, final answer. In this lesson, there is a theorem that we need to jot down. It's the remainder theorem. I'm going to kind of talk about the remainder theorem here. So be sure you're okay and caught up on example 4. And here's the remainder theorem for you to write down. Remainder theorem. If a polynomial f of x is divided by x minus k, the remainder is the same as the polynomial evaluated at k. If a polynomial f of x is divided by x minus k, the remainder is the same as the polynomial evaluated. Hey, this little theorem's going to save us some time. That we won't have to do so much long division or synthetic division, either one. Example 5. Find f of 4 if f of x equals negative x cubed plus 8x squared plus 63. So put this in your calculator. You're going to put the opposite of 4 cubed plus 8 times 4 squared plus 63. When you enter that in your calculator exactly like that, be sure you got those parentheses where they should go. You're going to get 127. Now, just to prove that this remainder theorem is true, let's do synthetic division with this one. 4, negative 1, 8, 0, 63. I got a negative 1, negative 4, 4, 16, 16, 64. So, I've just shown that the remainder I get when I do synthetic division is the same answer I get when I just substitute that number that I did synthetic division with into the function. The reason that's helpful is because sometimes they're going to ask you, is 4 an answer to this? An answer to a function could be called a solution. It could also be called a 0. So, you need to know these things. A 0 of a polynomial is the same as a solution of the polynomial. So, answer, solution, and 0 all mean the same thing. Answer, solution, and 0 all mean the same thing. One way they can be found is by looking at the graph and finding where the graph crosses the x-axis. So, hey, 0, solution, answer, and x-intercept all mean the same thing. We can find where the graph crosses x-axis, and we're going to find the answer to that function. Two more ways that we could find the answer are by substituting k into the function to see if it is a solution. Or we could do synthetic division. If they ask you, is a number a solution, then you could substitute it in there, or you could do synthetic division, or you could use your calculator and graph it and see if it crossed there. That's a good place to stop, part.